This video goes over more features to expand upon the initial workflow of Impulse. You can also read about these features on the Lese knowledge base website, which contains the full Impulse manual as well as other guides. You will eventually want to use your own 3D models in Impulse, and that can be accessed by selecting Import 3D Object here. Impulse is able to handle a lot of common formats such as OBJ, DAE, and STL 3D objects. Some of these formats have their drawbacks though, such as STL objects not being able to store material data. Select your 3D object through here, and wait a moment for Impulse to import it. More complex models may take some time. Now that the model has been loaded, Impulse has a feature to automatically create and assign materials based on textual analysis of the material names. For example, if you exported a model that had materials assigned that were named brick, Impulse's material auto creator would see this and decide to automatically create a brick wall material from the internal materials library and assign it to the relevant surfaces. If you don't want to use this feature though, you can just specify Impulse to create blank materials, or alternatively, just do nothing. A core feature of Impulse is the ability to assign acoustic materials to various surfaces in the geometry. To start with material assignment, first open up the Materials tab. There are two ways to select surfaces, either as polygons or as points on the side. You will notice that materials are not simply selected as individual triangles. This is because when scenes are first imported into Impulse, the various triangles that make up the geometry are grouped according to their relation to each other. If triangles are touching, if they have identical normals, and if they have identical materials, then they will be grouped together. This allows for complex flat surfaces that would have a lot of triangles to be treated as one continuous grouped surface. To assign materials, click a surface on the 3D scene and shift-click to select multiple ones. When you are ready, you can click Assign on the sidebar to set all of the surfaces to match the currently selected material. Additionally, you can also do an inverse selection by doing Ctrl or Command-I. If you unassign materials from a scene, another button becomes visible to automatically select all surfaces that do not have materials assigned to them. Adjusting the acoustic materials is easy. The graph here controls how much sound a given material absorbs when sound rays reflect off of it, based on frequency. Bringing the values up would ultimately lead to a shorter and more dampened IR, and lowering the values would create a longer, brighter IR. You can also control the diffusion value, which just adjusts the randomness of specular audio reflections. So that if you wanted to simulate diffuse acoustics, you could just have a flat surface and turn up this value, as opposed to, say, going into Blender and recreating an actual acoustic diffuser. In Impulse, one acoustic simulation is permitted to be ran at once. This is why in the Simulations tab, only one of the available sources is able to be specified as the source to simulate from at any given time. This is due to the large amount of memory that individual simulations may take up. However, any number of listeners can be selected at once, as listeners are all based upon various positions in an individual simulation. So not only can you specify multiple listeners to render, but you can also render them all in one go, as well as save them all at once in a batch. The Classroom demo project has multiple listeners already, but let's add a few more. Add objects to the scene by clicking this plus button here and specifying a new listener. You can move the listener around easily with the on-screen controls. Once this is done, we can simulate the acoustic space. Now that this is complete, let's go into the render settings. Ensure that all of the listeners are selected, and then press the render button. Since these IRs were all mono, it will be much quicker than the spatial modes with large amounts of channels. If we look at the output section now, we can look over the various IRs that were just created. The spatial energy visualizer is disabled in this case as the audio was mono. Now, let's batch save all of these impulse responses. Since multiple IRs have been created, a separate section for saving has shown up, the batch save option. When batch saving, the IRs will be named programmatically, the same way that they are named in the list box above. We can also specify the IRs to be normalized, and the way that they are normalized can either be done individually or based on the highest peak of all of the stored IRs. Thank you for watching. In the next tutorial, we will go over Impulse's simulation and render settings in detail.